I'm in Cork, Ireland's second largest city. This picturesque place may be 1,500 years old, but when it comes to waste, they're on the cutting edge. With a processing plant that's almost literally turning guano into gold. At the centre of this environmental alchemy is scientist Paul O'Callaghan.
Joanne!
Paul! You're not proposing a dip in this pool, are you?
You can go if you want.
I hate to think what's actually in this pool.
Not for swimming.
Hi, very nice to meet you.
Likewise, indeed.
So where are we exactly?
You're at the Carragrennan Wastewater Treatment Plant in Cork City, Ireland. Every day, 40 million gallons of sewage comes through this plant from about 250,000 people. This is the first step in the treatment process where we take in the water and we allow waste to settle out of it.
Delicious, quite a cocktail going on down here.
Yeah, that's quite a mixture.
But where I was going was even less appetizing. I can only describe it as Dookie's Inferno.
Okay, look, I brought you here today to give you an idea of what we're dealing with.
This stinks.
It does indeed, I agree. It's a powerful smell, so is the energy that it can potentially produce.
You seem fine.
I'm used to it. Currently, they dewater it, they dry it, and they spread it onto farms. What we're going to look at next will be a technology which can take this and unlock some of the energy and the resources which are actually contained within it.
So I hope that where we're heading, I'm going to feel a bit less nauseous.
You will. Or you want to stay here another hour and you get used to it?
No, I don't want to do that. Let's go.
So all of that dried material, all of that dried sludge we saw in that building.
We smelled in that building.
Indeed, smelled. So still has energy locked inside of it. A lot of energy. That's energy which is going through this plant 365 days a year and in every city in the world that has a wastewater treatment plant. You can potentially unlock that energy, and we just need to change how we think about it to see it as a resource as opposed to a waste.
It was onto an experimental plant run by a cutting-edge company called Supercritical Fluids International.
So, welcome to our treatment plant. This is our demonstration facility where we can treat the sewage waste from 14,000 people. At a full-scale plant, you would be looking at more like 500,000 people to 1.5 million.
Okay, but is sewage sludge raw sewage at this point when it comes in?
It's pretty raw at this point. We're essentially mixing and blending the sewage here, getting it to one consistency, and then it goes into this feed tank, which is the first step in our process.
The treated sewage goes through pipes and into a series of pumps.
This is the next step, really, where we bring it up to pressure using these pumps. These are high-pressure pumps. We increase the pressure to 3,200 pounds per square inch.
Which sounds like a lot of pressure.
Yeah, it's an incredible amount. 3,200 PSI, it would be like an elephant standing on a dime.
Okay,
or
squashed.
Squashed, indeed, yeah. Or about 100 times the pressure in a tire of your car. Then we increase the temperature.
We've squished the poo, now we're going to cook the poo.
Exactly. Okay. We've squished it, and now we're going to heat it and bake it.
What kind of heat are we talking about?
You're talking 700 degrees Fahrenheit.
Wow.
That's hot enough to melt lead, about 500 degrees beyond water's boiling point.
I think I'm intimidated.
Come into the future.
All right, then.
I step into what Paul calls the hot room. It's here that one of the most difficult problems in waste disposal is dealt with.
Section of the reactor.
What to do with the water that makes up most of our poo.
So, organic waste, human waste, animal waste, they're mostly water. So,
even though it doesn't look like it.
Yeah, it's still 70 or 80% water. I mean, you and I are 70% water, and our waste is even higher percentage.
Remember, we spend $5 billion a year just processing our solid waste. And most of that cost is just to separate the water from the solid waste. What if we didn't have to do that?
Here, rather than trying to remove the water from the waste, we use the water. We use the water as a medium to destroy the organic material.
It's a breakthrough idea. Coming up, you think you know H2O. It can be a liquid, ice, steam. Well, guess what, science fans? There's a fourth form of water. And what these guys are doing with it might just change the world.
To get the inside poop on how human waste is being used for energy, go to planetgreen.com/Dean.
Joanne's in Cork, Ireland, where a cutting-edge company is taking the simplest ingredient imaginable, water, and using it to obliterate human waste and generate energy in a pollution-free way that's never been tried before. The human waste, partially treated, comes into the plant and is subjected to incredible pressures and temperatures up to 700 degrees Fahrenheit. This combination brings the water way past its boiling point. It's no longer water, it's not steam, and it's definitely not ice.
It's not a solid, it's not a liquid, it's not a gas. It's in a fourth state, supercritical. It's somewhere in between a liquid and a gas. It will diffuse like a gas, but it will dissolve like a liquid. And you get very rapid rates of reaction in supercritical water.
These reactions are so dramatic that engineers all around the world are racing to use this fourth form of water in nuclear reactors. That's because this fourth form of water, invisible to the naked eye, has enormous power.
Supercritical water oxidation will basically destroy any organic material known to man. Pharmaceuticals, explosive wastes.
Poo?
Poo, that's one of the easier ones to destroy.
Hazardous, toxic waste.
Absolutely. Any highly hazardous, highly toxic waste will be completely destroyed in this process.
In just 60 seconds, the piped-in poo is completely dissolved and broken down into its molecular components.
Supercriticals super quickly.
Indeed.
So much steam is produced from the water that it can power the entire plant and then some. Additional energy is sent onto the electrical grid for use by homes and businesses, and the carbon dioxide is sold as gas.
So what you see here in these beakers, that's what we started with.
Right.
Within 60 seconds, it was completely oxidized. We've decanted the water, and this is the ash which is left behind.
That's the silica.
That would be the silica.
The silica, a clay-like material, can be sold as an ingredient to make cement.
This is phosphorus.
And the phosphorus is used for fertilizer. So the waste coming into this plant is 100% recycled.
It's almost impossible to imagine that there aren't harmful byproducts from being able to do this.
You get complete destruction of all the material in there into harmless and safe byproducts. So we're actually releasing the energy, can export electricity back to the grid, as opposed to consuming energy in the process.
Who knew? It's all in the poo.
It's all there. You just got to figure out how to reuse it.
Dean, I really like what those guys are doing in Ireland. And I see no reason why you can't use supercritical water in the treatment for animal waste as well. I think it would really help fight global warming and bring energy costs down.
Well, it really will be exciting when they can finally cost-effectively extract useful energy from what we used to think of as waste.
It would be a revolution.
Yeah, perhaps the smelliest revolution in history. But if we all join in, maybe we can finally stop wasting our waste. That would be a good thing.